Hey class, Miss Johnson here, and today I'm going to go through some Chapter 7 test review for geometry and cover what do you need to know for your test. Okay, so the first thing you want to make sure you can do is to be able to calculate ratios. So an example, of the 4 pets owned, 3 are dogs. What is the ratio of dogs to pets? One of the most important things to note here is the order that it gives you. It says dogs first, 2 pets. So we have 3 dogs, 2, 4 pets. Okay? So that's how I would expect you to write that. Some of you like to write ratios as fractions. That's fine. Just note which one is the numerator and which one is the denominator. If I give you a picture and ask you what ratio is between the 2 pictures, remember we always go left to right unless the directions say otherwise, okay? With pictures, you always go left to right unless it says otherwise. All right? The next thing you want to make sure you know is be able to identify similarity based on a picture. So some things that you need to check for. Are corresponding angles congruent? Remember, when it comes to a polygon, all of the angles must be congruent. If you're talking about a polygon, all of the corresponding sides also must be proportional. They don't have to be congruent for the sides, but they do have to be proportional. You should be able to take each side from the first polygon, multiply it by the same number, and get to the second polygon. And one of the third things is remember that perimeters of similar figures are also proportional. I know some of you were questioning that when it came to the homework. All right, so let's talk a little bit about proportions. Let's look at our example. We have a 6-foot flagpole, okay? It's a 6-foot flagpole that casts a 5-foot shadow. And then we also have a tree that casts a 13-foot shadow. So if I back up the tree, so there's going to be 8 feet there, and this is a total of 13. I want to know how tall is the tree. Okay, so we have our tree, our flagpole. Okay, so this is how I would set up a picture like this. You'll have something similar to this on the test. And then you have to go and figure out what the height of the tree is, and we can do that by setting up a proportion. So 5 is our flagpole, the shadow for our flagpole. 13 is the shadow for our tree. 6 feet is how tall the flagpole is, and we're trying to figure out how tall that tree is. So now that I have my proportion set up, I can cross multiply. So I have 5x equals 78. And if I divide by 5, I have x equals 15.6 feet. Okay? 15.6 feet. All right, let's move on to scale factor. So remember, a scale factor is that number that you multiply to get from one shape to another. One important thing about scale factor that some of you forgot is that if you have inches on top, you need to have inches on bottom. If you have feet on top, you have to have feet on bottom. So if you're starting with inches over miles, you need to convert those miles to inches. You have to break it down to the smaller of the units, so that way you don't have a decimal in your fraction. Okay? So let's go back and look, what was the scale factor from the previous example? So if we go back and look, our scale factor is right there, 5/13. It's our corresponding parts on our triangles, okay? That is what we were multiplying by in order to get to our height of 15.6 feet. The next thing is similarity of triangles with parallel lines, okay? So here are just kind of the 3, I took 3 screenshots of the most important things here. So if a line is parallel, if we have 2 parallel lines, then we know, if these are parallel, we know that AB and BC are going to go together, and AE and ED are going to go together, okay? So it's going to be the same. If we have this side, it's going to be similar, proportional to the other side. Theorem 7.6, if we don't have the information that they're already parallel, and that's what we're trying to prove, talk about, then the way that we can say that they are parallel is by showing that these two sides are proportional. Okay, show that the two sides are proportional. And the last one is the mid-segment theorem. So last chapter we talked about trapezoid mid-segment theorem. This one's really similar, except you don't have two bases, okay? So the mid-segment equals 1/2 times the base, okay? The mid-segment, so the smaller of the parallel lines, it equals half of the base. Okay? One of the next things you need to know is that proportions with similar polygons, they're really honestly similar to proportions with triangles. I think you guys understand proportions with triangles pretty well. The only difference between triangles versus polygons is polygons, you can't use your side-side-side similarity. You have to do side-side-side, and you have to prove the angles. You can't just use angle-angle similarity because some polygons have several angles, and you have to prove that they are all congruent. And you can't use side-angle-side anymore. Remember, these are all specific to triangles, okay? Dilations. Biggest thing to remember, enlargements, the scale factor is going to be greater than 1, and a reduction, your scale factor is going to be less than 1. It's really the biggest thing to remember. And then identifying similar triangles, as we mentioned just a couple slides ago, side-side-side similarity, side-angle-side similarity, and angle-angle similarity are your best friends for that process. If possible, I recommend checking for angle-angle similarity first because you guys like the lazy way out, and that is the least amount of work if you can get it to, if you have enough information for that. Mid-segments in triangles, this is already a little bit about what we talked about. Just remember, I want to say it a couple times, this mid-segment equals 1/2 of this this base, okay? So the center line here equals 1/2 of your line down there. Proportional parts of parallel lines. Okay, so I took another screenshot of something that explains this well. If you look at, you have multiple parallel lines, 3 or more, and they intersect 2 transversals. Okay, so think of our dance transversals, but on a much more difficult level. Talking about the way the transversals are proportional. So again, the parts, the 2 different transversals, if you have those parallel lines, should be proportional to each other. Okay, they should be proportional to each other. And one last thing. There are no proofs on this test in case you have not heard me say that yet. If you have questions, be sure to ask for some help. But happy studying. Good luck.